catch up to you guys. So I get A is 25 degrees. So that means B, I like it, it's 50 degrees. And C, 105 degrees. How do you check your work? Add them all up and it's supposed to make 180. They do, yay. See, so these word problems are nowhere near as difficult to set up as the real, like, general word problems we did earlier, right? Sam is going 40 miles an hour upstream. Oh, God. Sam, just go home. All right, now look at this one. Let's do this one a little bit together because this... All right. So you got regular, performance plus, and premium. A bunch of P's, that sucks. Can you identify 3 ideas that will become equations? So let me start us off with one. There's the idea of total gallons of gas. That will become an equation. What's the second idea? Total amount of money. That's going to become an equation. And then the third one is just straight up. It just gave me a relationship between two of them. So I need 3 pieces of information because there's 3 things I don't know. The amount of each of those 3 things. So how with that 6,500 idea? What are my variables going to stand for, by the way?
Regular.
But what about regular? What about it? The amount of, right? The $3 is going to be on top of that to figure out total money. But what will R, if I use R for regular, what does it really mean? The amount of regular. Now these are both P's, but I'm going to use M for medium for mid-grade. Is that all right? M is performance plus. And P is premium. Okay? You could use X, Y, Z, A, B, C. I try to use letters that relate to what they are. So what's the first equation I can set up about this 6,500 gallons? How much regular gas did we sell?
Oh, 3R.
No. Does 6,500 gallons have anything to do with money?
No, 3 times as many gallons of regular.
Oh, no. I'm not even there yet. I'm just talking about this thing. There's this one, there's this one, and then there's this. That's where my 3 equations are coming from. So what equation do I set up from this?
R plus.
Yeah, there's R gallons of regular, M gallons of medium, the performance plus, and then there's P gallons of premium. So you almost always are going to have a, not always, but a lot of the time you're going to have a, just something where the 3 variables are added to be something. That's your total equation. 482 people came to a concert. Does that sound familiar? There's your total equation that you can set up. A plus K equals 482 or whatever it is. What about the money equation that deals with the 20,050? Yeah, regular is $3 a gallon, so 3 times how much regular I sold, plus 3.20 times how much the mid-grade I sold, plus 330 for the premium I sold, gives me $20,050. You know, it sounds right. Crazy gas stations making money all of it. So I got a total amount equation, I have a total amount of money equation, and then finally I do have that just straight up, here's an equation they just gave to me. 3 times as many gallons of regular as premium gas were sold. Now that's a little bit weird. 3 times as many gallons of regular as premium gas was sold. Oh shit, how do I tease that out? Which one was there more of, regular or premium? Regular. So regular is 3 times as many gallons of regular as premium. 3p. Again, that's English grammar, really. 3 times as many gallons of regular. So there's more regular. So you wouldn't say 3R equals P because then there's more premium. Whatever the regular is 3 times the premium. That makes sense. That's what it's saying. There's more regular. How much more? 3 times as much. All right. How in all hell do I solve this thing?
Put the value for R into the second equation.
The funny thing is, I want you to realize something. If I plug that value of R into both equations, then I'm only going to have M and P in my equations. I know R is 3P. Well, where's R? Here and here. Why don't I replace both of them with 3P? And then how many variables do I have in each of these equations? Just 2, M and P. Can't I solve for M or P then, using substitution, elimination, whatever? All right, try to finish that one out. Again, my hint for the first thing to do is just replace R with what you know it is. Rewrite those 2 equations and get your like terms together. All right, let me see. Let me try to catch up with you guys. So if we rewrite 1, putting 3p plus p, now it's m plus 4p. That's what number 1 becomes. Oh, crap. I forgot to unfreeze. Unfreeze. Sorry. You're like, you're here. Where is it? Oh, my God. All right. Ghost teacher. And now if I put 3p here, 3 times 3p is 9p. So if I put R, if I make it 3p, now it's 3 times 3p is 9p, plus 330p is 1230p. Oh, shit. So now I get 3.2m plus 12.3p. So that's what the 2 equations become. And make sure that looks kind of big. Oh, well. So if I put 3p in there, I get 9p plus 330p is 1230p. Is that cool? 9 plus 312, 30 cents. Now what do I do between these 2? What can I do? There's a few different ways to do it. You can either multiply this one by negative 3.2, right? To kill this. Or you could solve this for m and then replace m with what you get. You can use substitution, it doesn't really matter. Just going with the theme of elimination. If I multiply this one by negative 3.2, oh shit, we'll get negative 3.2m minus 12.8p, that's 3.2 times 4. Why did I multiply by negative 3.2? Why am I doing that weird shit? So that these 2 will kill each other, right? It really is kind of mindless on one. Whatever the hell this is, I'm going to multiply this by it, because there's a 1 here currently, right? So it's 3.2. I'm going to multiply negative 3.2, so they'll kill each other eventually. And now I got to do negative 3.2 times 6,500. Maybe somebody can help me. Let's do it again. 20,800. Neato. Negative. Oh man, how do we feel about that? Bless you. Bless you. So R equals 3p is an awesome piece of information. I can use it immediately, just use it. And then I get these two equations. And now I know it's a decimal. I know it is. We're the humans. We invented this shit. They should be scared of us, not us scared of them. 3.2m. I got to multiply by negative 3.2 so they will kill each other. If there was an 11.888872, I would multiply by negative 11.88872. I wouldn't think, oh my God, it's an ugly number. No, I'm going to multiply negative that to kill it. Okay. So when I add these together, what do I get? What's 12.3 minus 12.8? Negative 0.5. I like it. Negative 0.5p. So when I add those together, it was 20,050 minus 20,800. What's 800 minus 50? 750, and the bigger one's negative. You see why I could do that? Because the 20,000s kill each other, don't they? And they really do just have 50 minus 800. Well, that's negative 750. So I've almost got p. How do I get p? Divide by negative 0.5. And you get p equals 1,500. Sweet. 1,500 what? Gallons. I like it. So 1,500 gallons of the premium. What can I immediately get now that I know p? R. Yeah, I can get R. I love it. So what's R? And then finally, what's M? I can plug in 1,500 here for P. 4 times 1,500 is 6,000. So M must be 500. Because when do I add to 6,000 and get 6,500? M must be 500. All right, subtract 6,000. So I get M is 500. So I sold 500 gallons of the middle stuff. Lock it. Yes, sir.
How was the 6,000?
Oh, what was P? 1,500. And if I plug that in here, 4 times 1,500 is 6,000. How do you check your work a little bit here? Yeah, if I add these up, 4,500, 500, 500, 6,500. They add up to 6,500. If you add up all those gallons. I like it. Okay, that was semi-disgusting just because of the decimals, not because of the steps I had to take to solve it. The steps I had to take were the same as always.
How would you find like the division of the money? Like how much, would you just multiply the gallons by the price of?
Oh yeah, sure. If now you know exactly how much regular you sold, so you put 4,500. 3 times that is how much money I made from that.
Okay.
And then, so that's another way to check it is plug it in here and make sure it comes out to be $20,050. Yeah, I like it.
So, if it never mind.
Yeah, that's a weird question to kind of ask. How much money did you make from each type of gas? But that's how they would ask it. And then you just plug it into the second equation, get the parts. Yeah. I like it. Just so happy I don't play poker with you guys. Somebody has the homework sheet somebody have the homework sheet. I gave all mine away. You have the homework sheet like handy? Thank you. I just want to make sure if I assign a certain type of problem. 4, 5, 9, 13, 18, 23. No, sweet. Okay, good. 13, beautiful, beautiful. Okay. Who is that? Okay. I did not assign these kind of problems, so be happy about that. A chemist with their acid solutions. Right. We don't have a reason, or not that I know of, to burn off our fingerprints, so we're not going to deal with acid. Okay. Now, so that hopefully you agree. Now that wasn't the prettiest thing, but it wasn't that hard either. If you get something like this, that's kicked so much ass. Because now I can replace that with this immediately. And then I got two equations I can work with like old times. Just because there's decimals, don't let that make the problem infinitely harder. They work the same way as any number. They really do. The bulk of this class, good, I want to spend on is talking about these things called matrices. Why? Back on page 59. Not really sure why they put this out of order, but they did. So, let me ask you this. Really?
Yeah. Well, I don't know where it went, but that's it.
Oh, well, that sucks. Does everybody else have 59, page 59?
Yeah.
I'm sorry, man. You got the special one.
Yeah.
Your prize is you don't get to see that. Sorry, sorry. All right, let me make this point. Remember we did this problem? This is back on page 56. Right here I multiplied by 2. And you can see, why did I do that? If this was A, B, C instead of X, Y, Z, would that have affected me doing that? No. So what is it that really tells me what to do? Not the letters. As long as they're lined up correctly, they don't tell me shit. It's the numbers that tell me what to do. So I want to go into this idea of matrices with you understanding why we invented them, or at least one. We're going to do like this much of everything they could be used for. All right? But this is pretty useful, the little bit we do. We're trying to condense the work we do and focus only on what's most important. I don't want to have to keep rewriting X and Y and Z if they're really not that important. And they really aren't. Does everybody understand what I'm saying? Mm-hmm. If there would have been a 3 here, I would have multiplied this one by 3. Right? It has nothing, if these are both M's or both W's or whatever, as long as they're the same letter, I just care about the coefficient. So the first major thing a matrix does is that. So let's build our way. Let's see what the hell a matrix is, period. Right? So here are matrices. This is back on page 59. But some of us have. Sorry. It's weird. So this is a matrix, that's a matrix, that's a matrix. Even that's a little matrix. Little tiny matrix. So all a matrix is something that has these columns and rows. Right? Have you ever used Excel? Ever seen Microsoft Excel, the spreadsheet? A lot of what it does is based on matrices, and you can see why. You have columns that mean shit, and then you put data below them. Right? Like I use Excel for your grades. Test 1, and there's a bunch of grades, and a test 2, there's a bunch of grades. Quiz 1, there's a bunch of grades. Right? So this idea of matrix is just an organizational idea to begin with. But then math came along and said, look at all this shit we could do. Oh my God, you don't even, of course you don't know. A lot of you guys just saw them for the first time. But there's so much shit you could do with matrices. We're not going to get into all of it. We're going to cover the bare minimum. So that's all we got time for. Most of the time we call a matrix, these are the names we give matrices. Like this might be matrix A, and this might be matrix B. We give them capital letters. It's just the convention. Okay. So notice that a matrix has rows and it has columns. So how many rows does this have? How many rows? 3. And how many columns? So I would call this a 3 by 4 matrix. Right? Like a 2 by 4 piece of wood. It's the dimensions of the thing. So what? How big is this? You almost can't go wrong. 2 by 2. How big is this? 4 by 2. It's always this way cross this way. So 4 rows, 2 columns. How about this guy? 1 by 1. Little 1 by 1. Okay. All right. So again, this is just, all right. Also to let you know, a lot of you guys are not going to buy into a claim I'm going to make that matrices make it easier and quicker to solve systems of equations. The reason you're not going to buy into that at first is because you're not used to using matrices. Right? So I will say this. If you have somebody who understands matrices, they will be able to solve systems of equations faster. What's our first thing going to be? Get used to how matrices work. And your brain's going to go, oh, what do I need this? But can you imagine, I really want you to imagine, do you remember when we added one letter on? Instead of just X and Y, I added Z in for chapter 9. How much more work was that by hand? A lot. Can you imagine, let me add one more letter in, which means I add one more equation in. Shit. So, once we learn how to solve using a matrix, when I add one more letter and one more equation, the amount of work is barely more at all. Barely. You just keep doing the same thing and just like, oh, let me just do it one more time. Bam, I got it. Add one more, let me just do it one more time. Bam, I got it. I mean, so once we learn the algorithm, once we learn the steps, then it doesn't matter how big my system is. The matrix just gobbles it up, right? So that's one thing to keep in mind. Okay, so let's talk a little bit more about matrices and how they work. We reference elements of a matrix using this type of deal here. So this would be the first row, first column. Second row, first column. So let me write that here. Second row, first column. So this is the third row, first column. Do you guys see that? So this element here, let's say this element right here. And this is matrix A, so let me give it little A's. This will be A what? What row is that in?
2.
Second row. What column is that in?
3.
So that would be element A23. It's a lot like latitude and longitude, really. You're just locating where something is. Where is that element? Second row, third column. Second row, third column. How's that? Delicious. I like that. That's interesting. Normally I'm the one that's like, that's yummy. What the hell are you talking about? Okay, so what element is this? Let's call this C. So let's be C. 2, I like it. I like it. Of course, this has only got the one element. A 1. That's it. All right, how much is that going to, bless you, how much is that going to come up in this class? Was that a cough? I don't know. I just said that just to be safe. That was a sneeze. Okay, now look here, help me out. This M has how many rows?
4.
How many rows? 3 rows. How many columns? 4. So it's called a what matrix? A what by what?
3, 4.
3 by 4 matrix. All right, that idea by itself is very basic. It's new, but it's simple. Thank God. I don't know what they mean. Has dimensions 3 by 4. I have no idea what they mean with it. Now, if I said create 3 by 2 matrix, Can you can you create an example? Just write it down. Create a 3x2 matrix.
1, 2.
Sorry. Create, just don't say it. Write it down. Alright, so what's it got to have? How many rows does it have to have? 3 rows and 2 columns. So it could be 1, 2, 3, 4, 5, -1. Whatever. It's gonna have some numbers in there. I like it. Okay. So I want you to really get this. We invented the number 7. Are you with me on that? We invented all the flipping numbers. Did aliens come down and say you're going to use this number for 7 thing? No. We invented the number 7. In fact, I don't know if you guys know this, but the number system we use is the Hindu-Arabic number system. Right? It's not the American number system. It's the Hindu-Arabic number system. When I teach 120, I teach ancient Mayan numeration system, ancient Chinese numeral system, Babylonian number system. So they all had different symbols, just like there's different symbols for the alphabet in certain languages, right? Greeks, Russians, they have different symbols for the letters, but they represent the same idea, right? So 7 exists. What's it good for? Would you say that 7 has uses, the number 7? Yes, it has uses. We like what? And you're like, I don't know. If there's 7 things, I'm going to say there's 7 things. You're like, what the hell? So a matrix by itself looks weird, and you'd be like, well, what good is that? It's sort of like somebody saying, well, what good is 7? You're like, I don't even know how to answer that question. What do you mean? So matrices by themselves mean something, just like 7 means something. We're going to look at one way they can be used. And specifically, how can they help us solve systems of equations? You with me? So we will focus on that. And that's all you have to know how to do. But I want you to realize that matrices themselves can be used in lots of different ways. Just like 7 can be used in lots of different ways. Right? Playing craps, it means something too. All right. Oh. Did I go too far? No, I didn't. So, here, let me go right here. So, tell me this. Are these lined up correctly? Or is there something not in the right place? Well, not the Y. The Y's are fine, but there is something in that column that's in the wrong place. Yes. So let's kind of correct that. And that really is just, let's just put it over here. Is that cool? It's still the same equation, right? X minus 4z. We just lined it up. Now look at this yummy phrase. Augmented matrix. It's like a battle suit. Put my augmented matrix on. So the way this works is, I already know what a matrix looks like in general, but the matrix that represents these equations, just write the coefficients down. Now that we've got these lined up, so the first column is the x column. I don't have to write x then. I already know it's the x column. So what I'm going to write right here is 2. The next column is the y column. What I'm going to write right here. Keep going. And then I put a line to make this -3. So that line shows me where the equal sign is. What goes here? 1. What goes here?
0.
Good. -4 is the z's. That's got to go in the z column. And then 5. And then here, 6, -1, 2, 10. So that's basic stuff. That's just setting up the matrix. We haven't even talked about what the hell to do with it next. But that is how you take a system of equations and represent it in a matrix. Okay, I like it. So I never have to write x's and y's and z's anymore. I just have to keep things in the correct column. So for example, do you see how, can somebody tell me, what letter would you kill? Okay, all right, let's just do this. Let's talk about these z's, because they definitely do just die. Well, how would I kill those z's? What would I do specifically? I have to add both equations together, right? I can't just put a 0 here. 0. No, I have to add this equation to this equation. Now look, what's that related to in the matrix? Which rows am I talking about? Row 1 and row 2. When I add row 1 to row 2, let's write down what we get. What do I get when I add row 1 and row 2? I get 3, -1, 0, and 2, right? All right, so, all right. Now, I'm not going to talk about was that the right thing to do or anything like that. It's just the first thing somebody really said for sure, and I went with it. But do you see how, I really want you to notice this. This refocuses us. What am I trying to do? I'm trying to make zeros. Because what does zeros relate to? What does that 0 mean I just did? I just killed a variable, right? Do you see what I'm saying? So now I'm not saying pick a letter, kill it, pick a letter. No, now I'm sort of like making this a game. Let me find something, make zeros between the two things, right? Now look at this first column real quick. What would I multiply this row by so when I add it to the first row, I get a 0 here? -2. So I'm trying to make zeros. Why? Because that relates to killing letters, and isn't that the whole purpose? Yes. To do that, it would be awesome if I had a 1. Why is a 1 awesome? Because it becomes anything I want it to be, right? Like if I wanted to kill, well, this is not a great example of it, but everything is nice here, shit. But if I had like a 3 and a 4 and I wanted to kill them, I'd have to multiply both of them by something so that they would kill each other. But a 1 is like, I'll become whatever you want me to, dude. Thanks, 1. So I call 1s lasers. They're sort of like, you ever heard of the lasers they use to kill tumors so they won't destroy anything else? They just kill only the bad shit, right? So a 1 is a laser, it's going to kill this. It can just become whatever I need it to kill that piece, right? That's weird, I know, but oh well. Now look real quick. All right. So that's a little bit of a feel for what we're actually going to be doing. But can you, before we do anything, can you rewrite? Let me help them out a little bit. Can you rewrite what that is in equation form? What does that matrix represent in terms of equations? What equations are these? And you can use X, Y, and Z eventually if you want to. So let me make sure. So this first row, if you call this the X row, what does this first row become? The X column, and this is the Y column. So this is X minus 4Y equals 10. And this one is Y equals 2. Now that's pretty good. But I still have work to do to solve it, right? This kicks ass, right? Look at all the zeros for number 1. Somebody just went to town and just killed a bunch of them. They did. What's this first row tell me? X is -4. Y is 7. Z is 2. Yeah, so that's like done. That matrix is done. I could just read the answer off. -4, 7, 2. I'm done. So whatever we're going to do to these matrices, this seems to be a goal. This is our goal. Why? Because then I know that is that, that is that, and that is that. Now, is this necessarily X? It could be A or whatever. It just depends on what the equations have in them, right? Maybe. Maybe. Okay. So, just to start things off, I'm going to do work with a 2x2. Let me see if they have a 2x2 for me. No, screw them. Yes, okay, good. Let me bypass all this other crap. All right. We're going to do this together. Now, let me say this. 2x2 matrices, systems of 2 equations, the matrix takes longer to do. I will admit that. But it's a nice little thing, so we're just getting used to how to use the matrix. 3x3, they're about the same amount of work. 4 by 4, a matrix kicks by hand's ass. And then anything above that is like, hello. 11 by 11. All right. First off, write that as a matrix. Don't say it out loud. Just write it as a matrix. All right, what do you guys get?
1 plus 3.
1, 3, 16, 6, 1, 11. Okay. What do you think my goal is going to be?
1001.
Good. 1001 with number, whatever the numbers are here. That's my goal. Why is that my goal? Because then I know what X is and I know what Y is. And if it's a 3 by 3, my goal is this. Right? So notice how the goal always has these 1s on the diagonal and 0s are everywhere else, because that means that I've killed every variable except 1 for each thing. Oh.
Why is it 4?
Where's it what?
Oh, no, that's a number.
No, I'm sorry. Number.
Why is it?
I'm with you. It's kind of funny because in grad school we used to always joke that when you're not sure, just put 4. Just the answer is 4. Anyway, it very rarely works for us because the teachers found out like we're never going to make it 4. Anyway, what is already in the right place? We're going to have to let go of one of these things, but do you see how 1? I know that one is 2, but see how that 1 is already in the right place? It's already the right thing, and 1 kicks ass. 1. Oh, you guys, you got to just go with me, okay? 1s are nice. 0s are necessary, right? 1s are nice. Why? Because 1 can become anything easily. But if there was a 2 there, couldn't I just multiply this by -3 and still kill that 6? Okay, so 1s are nice. 0s are the whole goal. I got to make 0s. If there's a 1, cool. I can make 0s easy. If there's not a 1, oh well. I'll make 0s however I can. 0s are the goal here, right? So what's wrong with this 6? What should it be? A 0. Okay, what do I do to row 1? So then when I add it to row 2, that will cancel. Multiply by -6. I like it. Now, on the first few problems we do, I'm going to do like more steps that are really necessary, but just so everybody sees exactly what the shit's going on. There's a lot of kind of condensing we can do, a lot of making it quicker that I'm going to slowly start to bring in as we get more and more comfortable with this stuff. So there will be more steps than necessary, just so you know that that's happening. Okay. You're like, man, it's taking a long time. Look at you. So I'm always going to tell myself what the hell I'm doing. So right now I'm just going to do row 1 times -6. Is that cool? Why are we doing that? So then when I add it to this row, I can get a 0 here, right? So now, what's row 1 now? -6, -18. Oh shit. 196. Okay. And row 2 is the same. I'm not doing anything to row 2, right? In fact, I really, really don't want to, because then it would be like, wait a minute, it's not a 6 anymore. Okay. Eventually, this will not be its own step. But right now, I just want to really make sure you can see this. Now, what am I going to do? What was the whole purpose of making this a -6? So I can add it to this. Now, watch. A matrix will only keep track of the best equations. So once I add these, that is a better equation than anything I had before, because it's going to be missing a letter, right? And where should the 0 be? In the first row. It should be here, right? So let me see if you guys get this. So what am I going to do now? I'm going to take row 1. I'm going to add it to row 2. And I'm going to put the answer in row 2. Why? Because that's where the stupid 0 should be, right? In row 2. So what do I get when I get that? I get -6 and 6 is 0. -18 plus 1 is Negative 17. Negative 96 plus 11. 85. Now watch what I'm going to do with row 1. Why did I multiply row 1 by negative 6? Why did I do that? So that I can add it to this and make it 0. Did I do that? Yeah. So let me take row 1 back to where it was. Let me make sure, yes. That's why I might do this problem again and show you exactly how I would do the problem with a matrix. Right? Why did I do this? So I could kill this one. Didn't I already do that? So why do I still need this shit? Can't I just go back to what it was? And I really want you to make sure. What does a row represent? What does a row represent? An equation. So anything I can do with an equation or with two equations, I can do with rows. So I can add two equations together. So I'm allowed to add two rows together. I can multiply a row by something. I can then divide it by that thing. Right? The only reason I multiply this up to negative 6 was so it can kill the other 6. Well, then bring it back down because it already did its freaking job. Plus, what's the goal? What am I supposed to have in this first row? 1, 0. Okay, good. Bring it back to 1. So look at this row. Thank the God something happens here. What do I need here? A 1. So what am I going to do with this row to make a 1 show up here? What am I going to do to this row? How do I make a 1 show up here? Divided by... divided by negative 17. So let me divide row 2 by negative 17. What do I get when I do that? Negative 85 divided by 17, thank God, is 5. Oh man, all right, I could feel it. I could feel some of you guys are like, screw this shit. I'm not going to do this shit. How many problems are going to be on the test related to this shit, Mr. Waller? Sorry I called it shit, but it's shit. All right. I understand. Part of me wishes you could we're just starting this. You've never seen these before. You're like, I've lived great up until now without it knowing what matrices are. But again, the whole purpose of this class is to open more doors for you. So since Excel is everywhere, and some of you guys are going to get a job in some big company at some level, and you're going to be using Excel spreadsheets. That's all there is to it, right? You know this is true. I use Excel spreadsheets. I'm not talking down about Excel spreadsheets. They're freaking everywhere. The more you understand what they're based on, the better you will be at using Excel. Right? It just is true. Okay. That's one little piece of this. Now, let's evaluate where we are. And again, what did I say? God, this is taking forever. We don't know matrices. I've got to explain every step. We've done more steps than we needed to. Right? Believe me, I know I've got to do this because I know how I would be feeling right now. And I'm like, we already know how to solve this shit. What the shit is it? All right. So what's not quite right yet? Looking at our goal. Yeah, the stupid 3 is supposed to be a 0. But look what we got here.
A 1.
And what can I multiply this row by so it kills this? And I don't want to lose this 1, do I? But notice it's a 0. It ain't going to screw with that 1. That's nice. Right? And that's why when I get a bigger matrix, I tell people, do a complete column. Get it right. Get that column right. Then move to another column. Get that column right. Because as you make more zeros, they won't screw with your 1s. Do you understand what I'm saying? If that was a 2 there and I added it, I would mess this 1 up, wouldn't I? And you're like, shit, man, I made that happen. What the? All right. So what did we just say? We're going to do this row?
Multiply by negative 3.
Yeah, multiply by negative 3. Let me write that. So this will be 1, 3, 16. 0, negative 3, negative 15. And then I can do what?
Add them.
Yeah, add these together. So row 1 plus row 2. Put the answer where?
Row 1.
Row 1, because I'm trying to make a 0 right here. Do you see how that step is more important than you might actually right now think? Telling yourself and me where the answer is going to go. Picking a place for the answer to go. Because you can put the answer in either row, but what's the row that makes sense? This one, because this row is beautiful. Why do I want to lose him? I don't. Poor little row. Oh, No? Okay, yeah. So what do you get? 0 and 1 is 1. Negative 3 and 3 is 0. Negative 15 and 16 is 1. And then I'm going to bring back the old row. See, so, and I'm not going to write this shit. Why did I need this shit? To kill him? Is he dead? Yeah. So let me bring back what it really is. What's the answer then?
5.
What's the answer? The answer. 1, 5. I like it. 1, 5. X is 1, Y is 5. Now, again, let me address this. Yeah, you could have solved that problem quicker, but what are we doing right now? We are getting used to matrices. If I said solve this problem using any method you want to and use the matrix, I'm going to look at you a little weird because it's easier to solve it just more directly, right? I'm not saying that this matrix is better for this problem. I'm saying this is another way, and it's better for most problems. 2x2s, I'm not going to use the matrix unless I'm showing somebody how the hell they work. All right, maybe. All right, so let me do that problem again. I'm going to do that problem again, but I'm going to show you all the shortcuts I would use. Right? And actually, there's not much here, but so let me write the original thing down. And you don't have to do any shortcuts at first if you don't want to. You do as much as you need to. I'm just trying to show you how to really use the full potential of a matrix. Right? Should be making everything quicker. So what I do is I do not rewrite the whole matrix. What do I want to do? I want to multiply row 1 by negative 6 so I can add it to row 2 and put the answer in row 2 so there's going to be a 0 here. Do you guys see that? That's what we did. Didn't we multiply row 1 by negative 6 and then add row 1 to row 2? But let me just do all this shit at once. Now here's what I do. Instead of rewriting the whole matrix, I put right next to this. What is 1 times negative 6? What is 3 times negative 6? 16 times negative 6. Do you see that? So I don't rewrite the whole matrix. So what the first row stays the same. What's the second row change? Negative 6 and 6 is 0. Negative 18 and 1 is negative 17. Negative 96 and 11 is negative 85. So I got to that same place much quicker than it did when we did originally. I mean, look at that, and now I'm there. Bam! So you can start to introduce these little shortcuts, so you don't have to rewrite the matrix. And when you have like a 3x3 matrix, the more you rewrite it, the longer the whole problem flipping takes. And then here you divide like we did before, right? What was it, 17? So that's here. And then finally, I would take row 2 times negative 3, add it to row 1, put the answer in row 1. And if you look, that's exactly what we did. We multiplied row 2 by negative 3, rewrote the matrix, and then we added row 2 and row 1. So here, again, I'm going to put right next to it. What's negative 3 times 0? 0. Negative 3 times 1. Negative 3 times 5. So when I add these, 0 and 1 is 1. Negative 3 and 3 is 0. Negative 15 and 16 is 1. And then rewrite that one, and I'm done. That was a lot faster. If I try to do it that way the first time, you guys would have been looking at me the way some of you are looking at me anyway. But I just want to point out, what did we do here? Didn't we multiply row 2 by negative 3? And then didn't we add those 2 rows together? So didn't I just do the same thing, just all at once? All right, what time is it? Okay, so let me just show you. I just want to show you the first couple steps here on this problem.
What page is that?
This is page 66. I will show you how to do this in the calculator, but that is just to check your work that you will show me that you do by hand, right? Okay. So, help me out. Let me just do the first couple steps here because it's already almost time to go, but how would I write that as a matrix?
2, 3, 1, line, negative, or 7.
I like it.
1, negative 4, negative 1, negative 3.
Now, do what I do. All right. It's such a habit for me because it so sucks to start doing a matrix. And then you go, wait a minute, that 3 was supposed to be, shit. Erase. So when you start putting things down in your matrix, make sure that you didn't forget any negatives, or a 3 didn't become an 8. Or this is problem 12 and you took something from problem 15 and you put it in there. Oh my God. Oh, this sucks. Now tell me this. Can you guys see what should be up here? What's my goal here? What's my goal? My goal is 1 0 0 0 1 0 0 0 1. Blah blah blah. Right? 4. No. What's the easiest way to get a 1 there? Don't cut this in half. You see how that would so suck? You never have to make fractions in the middle of your work. Never. So what's the easiest way to get a 1 there? Switch those 2 rows. What is that related to? Isn't that just switching the 2? Why did they put that equation first? Is there a reason that's equations first? No, there's no reason. So screw them. Let me just rearrange this so I get a 1 where I want it. Now technically, do you really have to do that? No. How would I use that 1 to kill these other 2 things? I would multiply this row by -2 and then add them together, right? And I would multiply this row by -3 and then add these together. Do you guys? Let me do those 2 things and then I'll let you out of here. Let me show you how I would do it. This might be pushing it a little bit, but let me see if you guys come with me. First off, let me go ahead and switch them.